Let's take a look at the RobotGeek Geekduino. The Geekduino is an Arduino-based microcontroller that's easy to program to interact with different electronic devices. You can then unplug it from your computer, power it externally, and it'll keep running that program. So first up, you've got this micro USB port. You can plug this into your computer and it's going to both power and allow you to program the board. For power, you're going to get 5 volts from your computer directly to the main chip on the Geekduino. This means that you can also use something like a cell phone charger or a USB battery backup bank to power your Geekduino. Over here you've got your DC jack. This accepts a barrel jack that'll fit directly in from a power supply, usually something like a wall wart, or sometimes it'll be a battery supply. This can take anything from 6 to 20 volts, though we recommend 6 to 12 volts. An onboard chip will convert that voltage down to 5 volts. So even if you've plugged 20 volts into here, your main Arduino chip's still going to run at 5 volts. We have a couple of switches here. One is for reset. For the most part, you're always going to leave this on auto so that the Geekduino can program properly. But for some applications, you don't want the computer to be able to reset the Geekduino externally. So you can set this over to manual and it'll disable that reset. The only way to reset it will be use this onboard reset button. This can be really handy for certain custom applications. Over here we've got this VCC switch. So like I said before, the Arduino normally runs on 5 volts, but for certain applications you'll want to run it at 3.3 volts. So you can just switch this over to 3v3, and then everything will go through a secondary regulator running the main chip at 3.3 volts and all the inputs and outputs at 3.3 volts. For most of our projects, you will keep this at 5 volts. Over here, you have an ISP connector. This is an advanced connector if you want to use external ISP hardware to program your Geekduino. This can be really handy for saving space, pins, as well as running your own custom bootloaders. But this is completely optional and not needed for any of our projects. We have some female headers over here that mostly represent our digital inputs and outputs. So any of these pins from 0 to 13 can be set as digital inputs or digital outputs. We also have pins marked PWM that can generate pulse width modulation signals. We'll go over that more in another video. We also have an extra ground pin and an analog reference pin. The analog reference pin is a reference pin for these main analog pins. Now the Geekduino actually has 8 analog pins. It has 6 pins on this female header and an extra 2 at the end here. The rest of this female header is all power pins. So you've got VIN. VIN ties to this barrel jack through a reverse protection diode, so it'll be a little bit less than whatever you put into here, but not too much. We've got 2 more ground pins, a 5 volt pin and a 3.3 volt pin. These 5 volt and 3.3 volt pins actually are going to be the same regardless of how you switch this. Then you've got an extra reset pin. This is the same pin that this reset button is on, so you can do some external resets. Like I said before, you've got your main at Mega 328 chip. This is the brain of the entire chip. And you've got some supporting circuitry and oscillator resistors, that sort of stuff. And over here you have an FTDI chip. This is the chip that allows the Mega 328 to talk to your computer over USB. Now I'm going to bring down the lights a little bit so that we can see some of the LEDs better. Over here you've got a green power LED. This is going to be on whenever the Geekduino is on, whether it's through the USB jack or the DC jack. Whenever you press the reset button, you'll see this red reset LED turn on. Over here you have your user LED. This can be programmed to do whatever you'd like. It's tied to digital pin 13, set as an output. We've got it just blinking on and off as the program runs. Next to this, you're going to have 2 more LEDs that are only going to be on when you're programming through USB. It's going to represent the data going to, back and forth from the 328 and the computer. So I've got a program with a lot of data so that we can see everything going through. I'm going to go ahead and upload it, and you'll see the red LEDs going back and forth, again representing the data going from the FTDI chip to the 328 and the verification coming back in. Once these LEDs stop flashing, that represents the end of the programming. You want to make sure in your Arduino IDE that everything has gone well. You should get a completed message that says done uploading. Anything else and there may be an error or a problem. Now we're going to take a really brief look at how the pins connect to each other. Here I have a breadboard and some components. We're not going to focus too much on this because for RobotGeek we're not going to get into breadboards, but basic idea is that we've got an LED, a resistor, and some wires, so these are all electrically connected through the breadboard. Means that when I plug into ground and power, it's 5 volts from my LED is going to turn on. I'm going to leave one end on ground, plug a little extension in, and before I said that these are all of the data pins. So these are how the Arduino communicates out with the outside world. That LED that I programmed to blink on and off is actually tied to pin 13. So when I plug into pin 13, my LED is going to turn on and off just like that LED on the board. In other videos, we'll show you how to program all the different ports to go both get data in and out and read analog data. Here we have the RobotGeek LED driver board. It has all the components we had before and then some, all on a nice, easy to use printed circuit board. So like before, I'm going to plug directly into Geekduino. In this case, I need my ground, my power, and my signal. And we'll see the light turning on and off. Now because I need these ground and powers, it can be difficult to plug in a lot of modules like this. That's where the sensor shield comes in. The RobotGeek sensor shield has a whole bunch of pins. They fit directly into the headers on the Geekduino. You can see the headers fit directly in. There's no overlap or bent pins. What's cool about the sensor shield is that you'll see all the numbers that you saw on the Geekduino itself. So DIO 13 is the digital input-output 13. But what's cool with these 3-pin headers is that you've got signal, voltage, and ground, all on an easy-to-use 3-pin connector. So now all I need to do is take a 3-pin connector from my RobotGeek LED driver, plug it in with the correct orientation. White is always to signal, black is always to ground, and my LED will flash on and off just like before. Using the Geekduino and the sensor shield, you can easily connect to a variety of boards. So you can easily control motors and read data from joysticks. You can even use the sensor shield in Geekduino to control a robot kit like the snapper arm. Here we've got it controlled from a gamepad, and we can control each joint in the arm. RobotGeek 101 is going to teach you how to code and how to use all of these different ports to connect everything from knobs, sliders, buttons, LEDs, and even motors. In the next video, we're going to go over setting up your Arduino and get it working with your computer.